chain through a life cycle assessment with a battery passport. It's required, I think, for the ESG standard that we cannot talk about a future electric mobility on the grid and also the storage is environmental footprint. This exactly of the life cycle assessment and digital framework of the battery passport become a game changer that the transformation of the sustainability for a measurable and a transparent data unlock a global market access. Well, actually, Mr. Bagus already said that it's very exciting that the speaker will be Mr. Renaldi as our director in strategic partnership, industry development and NBRS, then previously as chairman of the ID Battery. And also welcome to Mr. Dr. Robert Paul as a founder of CEO Minervo and world class for the environmental impact across the battery supply chain. And thank you, Mr. Bagus, for become the moderator. Okay, so a little bit about the International Battery Summit. So the International Battery Summit 2026 will be held in 26 until 28 August in Jakarta, jointly hosted by the National Battery Research Institute and also ID Battery Indonesia, is ecosystem of the Asosiasi Baterai Indonesia and organized with the Pamer Indonesia. This summit stand a pivot milestone for a future clean energy. Next, please. Our core of objective is a clear to a position of the Indonesia primary region of the global battery hub and aggressively driven of the strategic investment. We intend to become a capitalize of the critical mineral advantage, expanding integrated value chains and showcasing our long-term commitment to a sustainable growth. Our briefing of the theme of the summit become the empowering of the energy transition through the advantage of the battery technology and also the renewable energy storage and e-mobility. The capture of the full breadth of this mission is the summit build the 5 key technical of the cluster. First, about the research about the critical foundation of the battery value chain. Second is the scaling of the e-mobility charging infrastructure and market adoption. Third, for the government leadership of the national energy transition roadmap. And the fourth, investment of the industry growth across the battery ecosystem. And the fifth, for the Indonesia region of the global battery economy. Next. We have a map of comprehensive array of the strategic and also the include of the directly of the president vision on downstreaming and also leveling the Indonesia value chain and exploring AI-driven innovation and navigate high-level impact of the global battery supply chain. Furthermore, we will dive of deep circular economy through of the waste management and also the battery passport and ESG standard to support the Indonesia target of the net zero emission 2060. Next. So this one is the overview of the event of the IBS 2025. So to understand that we are going to let the incredible moment built during 2025. Last year, we brought of more than 350 stakeholders across the nation and international, and all the attendance is around 810 attendance, and with a massive 40% of the foreign participant representing 30 countries. We were honored that elite 80 speaker from the Ministry Energy and also founder of the National Battery Research Institute, Professor Evi, to international executive from the ID Battery and also sponsored by CATL, WAYU, and also the LG Electric Solution. The International Finance Corporation, IFS, is stable, also become our supporting knowledge partner. Next, please. So this is a snapshot about our event in 2025. We have been success for this event. Yeah, more than 1,000 attend and 100 speaker joining this event. Okay, next. And this is the last IBS 2025 speaker. So there is many speaker and in 2025, and they share many insight regarding the battery ecosystem in Indonesia and also in the world. Okay, next. So the event will be in Jakarta International Expo, G-Expo Convention. Yeah, will be held in 26 until 27. Yeah, and also one things that very important, there will be industry visit. Yeah, there will be industry visit that going to one of the biggest industry that already be launched by Mr. President. We're going to Katip and also we'll go to the PT Karsurin TBK and National Battery Research Institute. Next. So we get the strong international support and also from the government. Yeah, also this the momentum heavily back from the government that we get a support from the coordinator Ministry for Infrastructure that Mr. Ahaye also will be open for the IBS 2026. Next. So this event, not only summit, so this event also will connected with the battery show, yeah, and also we will have a gala dinner to have a network connection, and we will have the industry visit. Next. So this event will be in Jakarta Expo. So this is a new place for us because the enthusiasm of the International Battery Summit is very big enthusiast. So we moved the place to the Jakarta International Expo Convention Center and Theater. So this will be a more connection that we will if you guys join the International Battery Summit 2026. Okay, next. So this will be the layout of this event. Okay, next. And then there will be also open for the sponsor. So anyone here, if you want to sponsor this event, is still open. Yeah. Okay, next. So the engagement of the International Battery Summit for the webinar start right now as a part of the roadshow for the IBS campaign. We have been hosting a free, highly attended webinar. So today, June 25, we are hosting of the second major webinar that focusing briefing of the sustainable in the lithium-ion battery value chain along the Minervo and battery leadership. And the future of the energy transition unfolding right here in Indonesia. So we're looking forward for you to partnership of the International Battery Summit 2026. And if there is a question regarding for the registration, just click our homepage www.ibs2026. Yeah, the information regarding the summit and also all the information we already put in the website. Yeah, and thanks all for all, and thank you, Mr. Bagus, for guiding this event, and welcome Ibu Profesor Dr. Renat Evi Kartini, and to all participants. Yeah, look forward the International Battery Summit 2026. Thank you very much, and have productive, inspiring session by Mr. Renaldi and also from Robert Paul, and have a productive, inspiring session for the look forward to seeing all of the person to maintain in Battery Summit 2026. See you in Battery Summit 2026 August. Thank you.
All right. We've just heard the insightful opening remarks delivered by Bapak Muhammad Firmansyah, MBA. Please give a warm appreciation to him. Now we will proceed with a group photo session. We kindly invite all participants and panelists to turn on your cameras and share your best smile. Please, to all participants, you can open camera. and give the best smiles. Okay, to all participants, please. Okay, we are waiting. Okay, we try to capture. I count 1, 2, 3. Okay, next slide. 1, 2, 3. Okay, next slide. 1, 2, 3. Okay, thank you very much to Bapak Muhammad Firmansyah to opening remarks at the afternoons today. All right, now we will proceed the main session. Allow me to guide you through the presentation, discussion, and Q&A session. Now we will move to our first presentation session. First session is about the integrating international sustainability standard into Indonesia downstream battery ecosystem. Will be delivered by Bapak Rinaldi Istanto, MSc, as Director of Strategic Partnership and Industry Development, MPRI. To Bapak Rinaldi Istanto, are you ready? You have approximately 30 minutes to deliver your presentation. To Bapak Rinaldi Istanto, time is yours.
Hello, everyone. Thank you, Mas Bagus, for moderating this session, and also thank you, Mas Firman, to open the session of today's event. So, yeah, before I going to the slide, if I may ask the support from the team to share the screen. Yeah. Thank you. So, good afternoon, everyone, and thank you for joining today's webinar. Today, I would like to discuss an important transformation in the global battery industry, namely the battery passport. The key message is here is transparency is no longer optional. In the next phase of the battery economy, companies and countries will not only be judged by how much battery material they produce, but also by how clearly they can prove where the material comes from, how it's processed, and how much carbon it emits, and how responsibly it moves through the supply chain. So the battery passport is not just as a compliance tool, but it's also becoming a new standard for market access, sustainability, and competitiveness. Next slide, please. So, ladies and gentlemen, as we can see, the battery is the new oil, and the race to lead it, it's already begun. So, if we look at the demand of the battery, it's really massive. The battery demand is projected to grow massively toward 2040, reaching around 8,800 gigawatt hour globally. According to data that conducted research by World Bank and IMF with Lauren Berger, so the demand of battery will reach 8,800 gigawatt hour. This demand is driven by the electric vehicle, uh, renewable energy storage, and also scale battery energy storage. So, to play a major role in this battery value chain, the key is first securing the raw material supply, second enhancing the supply chain efficiency, third strategic partnership and collaboration, and fourth sustainably and ethical sourcing. So the key question is how then this we as Indonesia as a global number one global nickel producer can serve all the market. The key is by following the global battery standard. Next slide, please. Why does it matters? Because access to the global standard in the future will drive by battery passport, especially for the European Union country that will implement the EU battery passport by next year. It will increasingly enhance the proof of sustainability. The EU battery regulation set rules across the battery life cycle, including carbon footprint, due diligence, recycle content, collection, reuse, and recycle. So the logic is clear: no traceability, no compliance, and no market access. This means competition in the battery industry is shifting. In the past, the main question was who can produce the lowest cost, but now the question is becoming who can produce with credibility and sustainability. So for battery producing countries, this is major strategic shift. Cost competitiveness is still important, but it will no longer be enough. The winner will be those who can combine scale, quality, sustainability, and verified data. Next, please. Yeah, the battery passport introduced the idea of digital identity for battery. This digital identity contains key information about the battery, including the origin of materials, carbon footprint, material composition, performance, durability, and circularity related information under the EU battery framework. Information and labeling requirements include QR codes and also this changed the role data in the battery industry. Data become as important as the mineral themselves. Nickel, lithium, cobalt, graphite, manganese, and other materials still essential, but without reliable data and traceability, those materials may not be accepted by premium market. So the strategic question changed from who has the resources to who can prove responsible and low carbon production. Next. So the strategy shift. This slide reinforced the strategy shift. The battery passport is not only about reporting. It's about creating trusted digital record across the battery life cycle. This include information on recycled content, renewable content, battery material composition, end of life handling, dismantling, spare part safety, and circularity. For manufacturers and suppliers, this means that documentation cannot be treated as an afterthought. Traceability must be built from the beginning, from mining to refinery, precursor, and cathode material production, cell manufacturing, pack assembly, use phase, second life, and recycling. In other words, the battery passport is end-to-end, and it will reward company that can integrate physical production into digital verification. Next. So, of course, Indonesia has a major role. Indonesia has a big opportunity to win this game if we can integrate the battery passport into our value chain, since we are number one nickel producer in the world. So this gives Indonesia a strong foundation, but the battery passport reminds us that natural resources alone are not enough. The next phase of competitiveness will come from moving beyond raw material into higher value, traceable, low carbon, and ESG compliance battery materials. So the challenge for Indonesia is that global buyer will demand stronger proof of sustainability. But the opportunity is that Indonesia can position itself not only as a major nickel producer, but as a trusted supplier for the global clean energy economy. It will move up Indonesia into higher value added value chains. Next. So to move up the value chains, Indonesia needs to focus for strategic area. First, traceable integration. Indonesia must ensure that mining, refining, processing, precursor, cathode materials, cell, recycling, and end-of-life data are connected into one transparent ecosystem. Second, low carbon processing. Battery passport requirement make carbon footprint a critical metric. Therefore, the use of cleaner energy and processing facility will become increasingly important. Third, digital system. Traceability can rely on manual reporting. It needs robust digital infrastructure, data governance, and verification mechanism. Fourth, ESG certification. International certification and third-party validation will help strengthen Indonesia credibility in the global market. If Indonesia can combine resource strength with traceability, low carbon processing, and ESG credibility, the country can become premium battery materials hub, not just a raw material supplier. Next. So this is also why NBRI pushed this agenda, and NBRI also will play a significant role in this ecosystem. We pushed it because we want Indonesia to be global battery premium supplier, not only global battery materials producer. So that's why we are here in NBRI wants to support this initiative through five key function. First, standard translation. NBRI will help interpret global battery passport requirement into practical guidance for Indonesia battery value chains. Second, technical validation. Since NBRI has been established for 5 years, we have the capability to have a technical verification. We have been trusted by major OEM and battery player to verify technical validation of their products. So we also will play role in this battery passport ecosystem as a technical validation. Third, we will push the pilot implementation. NBRI will help lead pilot project with manufacturer, recycle, EV player, and best companies to test battery passport readiness in real operating condition. We also have our partners come here, Mindviro, which is our strategic partners to do the life cycle assessment and sustainability consultation. So yeah, we will push the pilot implementation. Fourth, we will play a role as the ecosystem coordinator. Battery passport implementation cannot be done by one company alone. It requires government, industry, academia, digital solution provider, and certification bodies. Of course, the establishment of NBRI 5 years ago coming as the ecosystem coordination, we are not limited ourselves as a research institution, but we also make the ecosystem for the battery industry. That's why we also have regular event yearly, namely International Battery Summit. This summit shows that we as the institution wants to make a platform for battery industry. Fifth, global partnership and capacity building. NBRI can connect Indonesia ecosystem with international standard initiative while building local technical capability and awareness. The strategic value is clear, and BRI can help transform battery passport adoption from a compliance burden into a competitive advantage. Next. So this is a strategic window, not a threat. The EU battery passport should not be seen only as a threat, but it should be seen as a strategic windows. We are currently coordinating with several key ministry to also aware about this agenda because we want Indonesia as a global premium battery producer. Countries and companies that adapt early will gain stronger trust, better market positioning, and long-term competitiveness in green economy. For Indonesia, this opportunity is significant. We already have the resources. We are building the downstream ecosystem. And the next step is to prove that our battery value chain is not only large, but also transparent, responsible, and globally trusted. So, the future of battery competitiveness will not only belong to those who control the minerals. It will belong to those who can prove full story behind the battery. So it ends my presentation. I think before we go to Mr. Robert Powell, and we're still waiting about his presence, we can have a quick Q&A. Thank you.
All right. Pardon. All right. Thank you very much to Bapak Rinaldi Istanto for insightful presentation. The presentation gives us knowledge that sustainability in lithium-ion battery industry is not only reducing emission, but also about the ensuring responsible sourcing and make better end-of-life management. Please give a warm appreciation to our first speaker. All right, let me check to our second. speaker. Oh, I'm sorry. All right. The Mr. Robert Cole.
Maybe we
Okay.
have
Now
a
we will move
Q&A.
to Q&A session about the first session that delivered by Bapak Rinaldi Istanto. To perhaps to our participant, if you have any question or request, please drop on the chat box at the Zoom. Okay, I try to open the chat box. Okay, Bapak Rinaldi, there are three questions from the chat box. The first is about from Yofi and Trif. Apakah untuk menjalankan baterai paspor diperlukan perapian standar protokol baterai? Bagaimana cara efektif menjalankan baterai paspor di tengah kondisi Indonesia yang mengalami keterlanjuran peredaran baterai tanpa standar? Alright, to Bapak Rinaldi, perhaps you can answer directly.
Yeah, I think battery passport is not looking about the past, but battery passport is the future. So even though currently we don't have any traceability in our battery system, but it doesn't mean that we cannot go to the battery passport. So what does it mean of battery passport? Every battery that has been produced has the traceability. So that's why if we currently already have two big battery manufacturer like Hyundai LG Indonesia and also CATIB, if we integrate the battery passport, every single cell that they produce needs to be have a traceability. So that's what the OEM, the manufacturing of electric vehicle in the Western world, in the Europe, requires. So they want to know whether the battery produced is coming from ethical mining resources and how is its process, whether it involve the ethical standard in the processing or not, and whether the carbon emission of this battery production is too big, so it will not help the environment. So that that is the mean and the objective of battery passport. So we acknowledge that currently we don't have the traceability yet, but the implementation should be started. Next year is the deadline from the EU body to start the battery passport. So yeah, we are not late, but we need to prepare. Otherwise, we will not optimize this opportunity. Thank you.
Okay, thank you very much to Bapak Rinaldi Istanto. And just information, battery passport will be mandatory at February 2027 in Europe, and we hope this regulation will be mandatory in Indonesia because we can save our local resources. All right, and the next question is from Animos. Okay, I try to rate this question. With the European Union and other major markets moving toward mandatory battery passport requirements, what concrete action should Indonesia prioritize over the next 25 months to ensure that the batteries produced in Indonesia remain globally competitive and fully compliant with future market access requirement? Okay, Bapak Rinaldi.
Yeah, I think the most concrete action we should talk the government, and the government should make a task force in order to push this agenda, because this agenda cannot be only driven by one company or one institution like NBRI, but it needs to have a multi-sector government coordination, because the upstream it's belong to the coordination of Ministry Energy and Mineral Resources. And also the environment belong to the Ministry of Environment. And on the downstream, it's belong to the Ministry of Industry. And the supply chains also needs to have a coordination with the Ministry of Trade. So it's really multi-ministerial coordination. So the concrete action, before we talk about, we need to prepare the system. We need to understand and aware that there is a battery passport requirement by EU that requires Indonesia to have a traceability in their battery production. If we don't follow this, it will be hard for our battery, especially from those two big companies, CATIB and also HLI, to enter the market of EU. Whereas we know that EU is one of the big markets in terms of the electric vehicle and battery energy storage system. So the concrete action one is the multi-minister coordination. So that's why NBRI now starting coordination with several ministry to push this agenda. Second, of course, after we have the multi-ministerial coordination, we need to make a task force, and the task force needs to be divided into working stream, because the working stream in upstream, midstream, and downstream will be different. We need to prepare the system, whether we extend from the global standard. I mean, there is several EU battery pass platform that has been established, whether we want to extend their license here or we want to build by our own. We need to prepare this. So after we make a task force, we need to prepare the platform, because it really requires the traceability from the mining. So the mining guy needs to report to to enter the data into the dashboard. So in the dashboard of mining, we can see where the mining come from, how big the nickel contain, how big the emission produced, then goes to the midstream. The midstream also needs to enter the data and goes to the downstream. The downstream also needs to input the data. So yeah, the system needs to be prepared. Yeah. So I think that's three key components that we need to have a concrete action. And also, don't forget about the regulation. In Indonesia, if we go without regulation, there is no such a mandatory. So the implementation, of course, will be not as robust as if we have the regulation. So that's why when we are preparing the task force, we also need to prepare the regulation of the battery passport and also the platform for the battery passports. I think that's my key takeaway. Thank you.
Okay, thank you very much to Bapak Renaldi Istanto. The last question from Pancha Nugraha. Okay, what is the ESG certification to move up the value chain? Is it important?
Of course, it's important.
ESG,
Yeah. ESG certification is important. It's not because not only because of the battery passport itself, but most the European or American company are now in the race of the sustainability. So usually they requires their their producer, their value chain ecosystem to have ESG certification. There are several companies that publish the ESG certification. So ESG certification now is like a requirement for the OEM in order for them to willing to buy your battery product. So usually they now require it. Otherwise, if you don't have the ESG certification, they prefer to find from the other resources which has ESG certification. So that the importance of ESG certification. I think the more basic, instead of the ESG certification, we should also consider good mining practice. I think good mining practice is the first step before we go to ESG certification, before we go to the battery passport. This also needs government push to make all the mining company to implement the good mining practice. We know that big company like Vale, Antam, Harita, they have implemented good mining practice, but there is also many company in Indonesia. It's still owned by local entrepreneur that are still not following good mining practice. So that standard also needs to be forced by the government if we want to be a champion in the global battery nickel players.
Okay. Thank you very much to Bapak Renaldi Istanto. Yeah, perhaps in this session it's only 3 questions to all participants. This question it will be we keep, and then your question will be answered in the next second session. Yeah, will be answered in the next second session. Now we will move to second session. Thank you very much to insightful presentation Bapak Renaldi Istanto. Please give warm appreciation to him. All right, now we will continue our second presentation session. The second session is about the life cycle assessment or LCA and carbon footprint accounting for critical battery minerals will be delivered by Mr. Robert Pell, founder and CEO Minviro. Okay. To Robert Pell, are you ready?
Yes, I am. Thank you very much for the introduction.
All right, you have approximately 30 minutes. To Robert Pell, time is yours.
Perfect. Well, firstly, thank you so much for the invitation, and a real pleasure to present here and talk about some of our learnings around life cycle assessment of critical minerals and how that relates to battery passports. So I will share my screen now. There we go. Perfect. Okay, so my name's Dr. Robert Pell. I'm the founder and CEO of Minviro. I've been working in the area of life cycle assessment for critical raw materials for over a decade now. I did my PhD on the topic and have since founded the company Minviro, and we're an established consultancy and software provider with really deep expertise in life cycle assessment, battery passport, data requirements, and a lot of other aspects of the regulations relating to this as well. So just to note, we're going to be providing some case studies in this presentation. Obviously, these are you're able to request them and use them, but obviously you just need to note that they come from Minviro, and some of them are from commercial projects. Just to give you a bit of context for those who don't know Minviro, Minviro is a company based in London, but we also have offices globally. We have a team in China and in Australia, as well as a team in the Netherlands. And we've had a number of projects and collaborations in Indonesia, which has been a real pleasure working with critical mineral projects as they develop and operators. We provide both consulting and other sort of data solutions and software, which I'll present a little bit because I think it's really useful to see practically how you deliver life cycle assessment with technology, which I'll show later. A lot of the work that we do with our clients can include alignment with certain regulations. So historically, that's been more aligned to the ISO standards, so the ISO 14040 and 14044 standards, which relate to life cycle assessment. But as regulations have been evolving, we're now seeing sort of alignment with other requirements, whether that's EU battery regulations, Article 7 Delegated Act, that will still to pass, as well as other sort of sector-specific frameworks as well. You can see we've got some photos here of some of the conference we presented recently in Indonesia. That's our international director, Phoebe. And then we also have a workshop that we did there below as well. we're in quite a unique position at Minviro, where we have the pleasure to work with companies across the value chain. So we work with mining companies, refineries, we work with component manufacturers, in the battery value chain, might be cathode manufacturers, anode manufacturers, or cell manufacturers, as well as working right downstream with the automotive companies as well. So it's very privileged position to be in, because you understand, what they're looking for. The languages that they use might be slightly different in terms of what they classify as different scopes of emissions, or how they perceive risk. And so when we think about the battery passport is, in essence, really trying to capture the essence, the metadata, all the credentials across this whole value chain, which contains multiple companies. And that's inherent in the life cycle assessment approach as well, which I'll introduce in a moment. But you're really trying to capture a full view of a product, considering its full journey through life, from a material in the ground, then ore, as it gets refined, and then being then made into a useful material and product for things like batteries. We also do a lot of work in the research and development field, so deep research, looking at methodology development, but also creating additional high quality data and models. And a lot of that work actually is in the battery value chain. We have our proprietary battery materials database, which is a database for all the different production pathways for those key materials for batteries and cathode materials and anode materials and other materials going into a battery. And that's really important because, again, the battery passport is really trying to capture the specific impacts of every battery based on its full value chain and history and use case. A lot of our material that we provide, especially from the research and development side, we really want to advance the science and share the knowledge that we've gained. So we publish a lot of white papers that are freely accessible on our website. There's a few that might be particularly relevant for this audience. One being looking at batteries specifically, life cycle assessment of different battery chemistries, looking at NMC. We then have a specific deep dive on nickel, different production pathways for nickel, looking at nickel sulfate and seeing what some of the core drivers of those different impacts are. And we've also looked at the end of life of batteries, looking at the circular economy and doing some modeling to assess, okay, well, what actually are the opportunities for impact reduction from collection and recycling of those battery materials and putting it into a systems dynamics context. So actually looking at, okay, well, what happens with the available battery chemistries on the market. And that case study is based on the UK, but it would be a very interesting thing to apply in Indonesia or more broadly. So I'm going to start off really from the basics because life cycle assessment is a relatively niche topic. There's a broader topic of sustainability. You can maybe narrow the topic in a little bit to product sustainability. So life cycle assessment lives often within that area of product sustainability. And I think a lot of people will be familiar with the concept of a carbon footprint. So what's the carbon footprint of a mobile phone, or what's the carbon footprint of a battery or a car? Now, fundamentally, life cycle assessment is the underpinning methodology that would enable you to calculate the carbon footprint. But life cycle assessment really covers a broader range of things. So it covers a broader range of impact categories. So beyond carbon, things like water, land use, which I'll touch on in a moment. But it also really considers, the fundamental philosophy around life cycle assessment is that life cycle thinking across the full life of a product, from cradle, so from the material in the ground, to grave, which would be the end of life of the product. Or you could even extend that to cradle, where you'd find a new use of that product in a more circular economy model. So the very fundamentals, life cycle assessment is a scientific methodology used to evaluate the environmental impacts of a product or service through its entire existence. So again, repeating what I said, from cradle to grave. But there are some additional things that you can change with that, from cradle to cradle, or even extension of that. The environmental impacts is an important point because it's beyond just carbon, even though some regulations just focus on the carbon intensity. So, for example, the Delegated Act that's in draft would indicate that only the carbon footprint of batteries is going to be included in the battery passports as we understand, as well as other metadata such as circularity metrics and some other metadata as well, like that might be included. But life cycle assessment fundamentally captures a broad range of impact categories, and some of those impact categories will be very alien or unfamiliar to people, but some will be much more familiar. But why that's useful is, and we'll talk about this as we go through to case studies and examples, if you are optimizing to reduce the carbon footprint of a product, are you having any unintended consequences elsewhere? So are you optimizing for carbon, but having a trade-off and a negative impact for, say, land use change, or for a water footprint, or maybe for impacts on ecotoxicity or things like this? And that's really what life cycle assessment helps to sort of consider, that broad trade-off across multiple impact categories. Some typical questions that you might be able to answer with a life cycle assessment is, what is the total carbon footprint of my product, considering its full journey? And so if we, again, I'm going to be talking about batteries a lot because obviously we're very focused on that in this topic, and I think the audience is interested in that. When we think about a battery has a huge number of tiers of the value chain and a huge number of stages to get from maybe the saprolite ore, the nickel ore in the ground, or ilmenite going right through to the final nickel contained materials in a battery cell in a car being used. There's a huge number of stages and a huge number of actors. So you obviously need to do, it's quite a lot of work and quite a lot of time consuming activity to actually collect all that data and stitch it together in a coherent way to be able to do that carbon footprint calculation. Now, you also might want to know, in that battery, where exactly are those impacts occurring? Because that's a really useful bit of information, because if you know what are the opportunities for impact reduction, if, for example, all your impacts are coming from, say, let's just say a cell manufacturing stage, then you might be able to consider what alternatives exist in terms of technologies in that cell manufacturing stage that could reduce that impact. Another question is, are we shifting environmental burdens from one stage to another? So I talked a little bit about shifting burdens from one impact category to another. So shifting burdens from carbon footprint to maybe water use or to land use change. But you can also shift burdens across the life cycle of a product. And a really good thought experiment for this is, like, you fundamentally think about, okay, well, why do we care about batteries? Why are we looking at electrification of transport? And it's really because if we look at the cumulative impact of electric vehicles versus a combustion vehicle, the idea is that electric vehicles have a lower cumulative impact. However, there is burden shifting in terms of where the impacts occur. In a combustion car, a lot of the carbon emissions come out of the exhaust during the use phase of the car. Whereas in an electric car, you might have increased burdens on the environment in the manufacturing stage, but you have reduced burdens in the use phase. And so that's what we mean when we're thinking about, are we shifting environmental burdens? And then you obviously want to measure that in the cumulative impact over the full life cycle of the product. A really common thing that we see is a really valuable use of life cycle assessment is when we're exploring how to do things differently. Like innovation is so important, for improving efficiency and driving down cost and, competitiveness. But it's also important to analyze these technologies within the context of life cycle assessment. So how does our technology compare to traditional alternatives? Is it worth investing, all this money to try and supersede this technology? And what are the consequences of that from an environmental standpoint? And then, there's obviously the marketing aspects of it. Like, a lot of companies want to say, yes, our material sourcing or our product is truly low carbon. Can you make those environmental claims? And that's a very big topic and a difficult topic, because there's obviously regulations around that and different ISO standards. And you may be familiar, for those that are familiar with the life cycle assessment world, there's a topic called, there's things called environmental product declarations, which are a form of an LCA, but it's really around a framework for making environmental claims about a product. I'm going to just highlight, this is probably the most famous diagram for the life cycle assessment world. It shows you really the approach of how you conduct a life cycle assessment. You would first start with a goal and scope definition. So before you start, you need to work out, okay, what are we measuring and what's the objective? Are we just looking to measure the impact of a particular product? Are we looking to measure the impact, the carbon footprint of a battery cell at the manufacturing gate? Now that would be in the goal and scope definition. Once you've done that, you go on to the next phase, which is the most time consuming, which is the life cycle, the inventory analysis, or the life cycle inventory data collection and consolidation approach. That's where you really need to collect all the data. So if you think about a mine site, you need to know exactly how much diesel you're consuming. What are the direct emissions coming off the equipment? Are you using explosives? Are you using water? What's the production volumes? All of that information needs to be collated across that whole value chain. And that's the inventory analysis. The next stage is the impact assessment. So that's where you translate all that inventory to the environmental impact categories, which I'll talk about in a moment. And that's how you translate that inventory data into, say, the carbon footprint of your product. But the whole time you need to be doing that interpretation phase. So you need to be reflecting on, okay, is this data suitable to meet the goal and scope? Is the interpretation, am I using the right impact assessment methodologies for the goal and scope? So it's really important that that interpretation happens in parallel of your LCA. And this is just repeating a little bit what I said, but really, if you look at sort of an example of an extraction and processing and then transport of that material, you'd be collating all these inputs and the outputs, which is the inventory. And also one thing that's very important, which makes things a bit more complex in an LCA, is it's very rare that you only produce one product. It's very common to produce multiple products or co-products at different stages of the system. And the reason why that's important to consider is because obviously if you collect all this data, you need to share the burdens across those co-products. So how much of the inventory is assigned to, say, ore grade 1, or how much is assigned to this main product and how much is assigned to this co-product? It could even be an aggregate co-product or semi-waste product that you need to consider as well. I'm not going to talk too much about the scopes of emissions because this is really a bit of a conflation between corporate sustainability reporting and product sustainability reporting. But in a lot of corporate reporting, they often talk about scopes of emissions, and that basically refers to whether the emissions are direct emissions, whether it's embedded in electricity that's consumed, or whether it's fully sort of upstream other chemicals or other materials inputs or downstream inputs as well. And this could be a useful way of framing it when you're looking for optimization of your impact. And I'll show you this in a bit of a demo towards the end of how we could look at, say, for example, electricity impacts across your whole value chain. So I mentioned that life cycle assessment can cover a broad range of impact categories. In the European recommended selection of impact categories is known as environmental footprint, and that covers 16 impact categories. And some of these, as I said, might be very familiar to you. Climate change, for example, ozone depletion was a big issue over the last few decades previously. But there's other impact categories as well, which can be particularly important for certain sectors. So, for example, water scarcity footprint, land use, acidification, particulate matter, respiratory. And that's a really important one. There's a lot of human health impacts from, for example, PM 2.5 or particulate matter related issues. So imagine you've got a project which you might be consuming electricity, but if all that electricity is coming from maybe quite an old coal power plant with limited sort of capturing of particulate matter, then that might have impacts not in the geographical location of where your manufacturing is, but in your value chain. There's also that you can see that there's a bit of complexity in terms of how you model, and one thing that's been criticized of a life cycle assessment approach is the flexibility that a practitioner has often had to be able to maybe adjust what is included in the life cycle inventory. So that would be referred as the system boundary. So what you include and what you exclude, or how you allocate across those co-products. There are a number of expert judgments that life cycle assessment professionals would typically have to make when they're conducting a life cycle assessment. And because of that variance, it's being very difficult to make comparisons across, one project to another. And so a reaction to that there's been standardization. Standardization has occurred both from voluntary or like industry associations, or through, like, as I mentioned, the EPDs previously, which is, sorry for all the acronyms, but an EPD is a form of an LCA. But they create, and again, sorry, another acronym, product category rules, which again gives you the rule book for how you would conduct a life cycle assessment. The way to think about it is it's fundamentally like a recipe, following a recipe book for how you would do the life cycle assessment. One other thing that we often advocate for, especially at Minviro, is saying that the earlier you can conduct a life cycle assessment, whether it's a mining project or through product development, the bigger opportunity you have to influence decisions that have the biggest opportunity to reduce the impact over the life cycle of the product. However, you have a counter to that, which is you often have limited data quality and there's greater uncertainty earlier on in the project. But there's often, when we work with mining project developments, we often work at the best stages, pre-feasibility and feasibility, and then work through to project closure. There's also some specific challenges or specific considerations that that are unique to the critical mineral LCA. So one is, I mentioned allocation. So, you have different choices of how you allocate. You can allocate the impacts across those co-products based on the economic value of those different products. You can also allocate across the mass of those different products. There's also different geological drivers. And that was actually the very topic of my PhD. And I won't go into too much detail on that today, but if anybody wants to catch up on that, I'd be more than happy to talk through that. I spent a good 3 years of my life on that topic. There's also industrial hotspots, which sometimes don't necessarily neatly fit into the impact categories that we have today. So how do you deal with tailings? How do you deal with some of the novel chemical reagents that are proprietary, and process water management? There's quite a bit of complexity around that. There's also quite significant regional intensity in critical mineral LCA, which we've highlighted in a lot of our white papers. And one thing that is becoming more important is this data hierarchy. So when we talk about the Battery Passport, the Delegated Act, there are requirements for primary data. And so it's very important to get this primary data, get these LCAs for site-specific data. Otherwise, it'll be difficult for the regulations, for the downstream companies to comply with regulations. So I'm going to jump into a couple of case studies. So I've talked through kind of fundamentally what a life cycle assessment is. And now I'm just going to show you a quick visual of what an example of a NMC 811 battery cell LCA results might look like. So this is a Sankey diagram where the width, so you can see it looks a bit like I suppose an octopus with too many legs, but you can see that the climate change impact, the width of this is a cumulative impact of the production of that battery. And then you can see one stage back in the supply chain, we can see the impact contribution, the relative contribution from the battery assembly stage, the cathode, the anode, and the electrolyte. And then in the battery assembly, we can see a majority of the impact is coming from the energies being used, and we can see most of that energy is being used in a dry room and cathode drying. And then we can see going through the PCAM, we can go and see the materials, and then we can see the relative contribution of the nickel sulfate hexahydrate, and then the particular production route in Indonesia. So for context, this is this is not a real supply chain. This is just an indicative example of how you would visually look across a value chain to understand where the hotspots might lie. We also had this is a paper that's from 2023. So we've got a few updated models on this now, but this was a paper that's publicly available. So this is on a report on the web, on the VDA's website, so the German Automotive Association, which looks at different carbon intensities of producing nickel contained in nickel sulfate hexahydrate. And you can see that the relative contribution, where the impacts are actually coming from, whether it's And in these examples, there's a limited contribution from the primary extraction phase, which would be the equivalent to the mining. There isn't significant impact contributions to the upgrading or transport, but in the chemical processing stage, which is obviously quite a large stage, is a significant impact contribution. Again, that's a public document, so you can dive into the details, and we have a few other nickel white papers that shows you where the hotspots are. This is an example with a lithium LCA, and I wanted to show this as an example because we can really demonstrate the value of LCA in terms of impact reduction potential. So you can see an example of it. This was the starting baseline of the LCA, where we could see the carbon footprint for 1 kilogram of lithium hydroxide. And then we explored different decarbonization technologies that could be applied here. And you can see the relative impact reduction potential for those technologies. So we looked at technologies like hydrogen roasting rather than natural gas, solar electricity for the chemical refining step. What's also very important to look to combine this type of work with is life cycle costing, include the economic cost of these changes. And that's kind of what you see here from a marginal abatement cost curve. I put in this slide just to sort of highlight what I think best practices are for developers and processors in this value chain. One is include LCA in the earliest design stage possible. The cost exposure is usually pretty low at this stage because you're really just doing a high-level indicative LCA that you probably wouldn't communicate to the public. I would really recommend around the importance of collecting primary data as early as possible, and again, working with service providers to understand what data they should be collecting as early as possible and have a process for that. Model decarbonization optimization with marginal abatement, so economics in mind. Think beyond carbon. So track these other impact categories because they might not be regulated in the Delegated Act today, but the regulations are evolving and they might be a risk factor for businesses. And it's important to also consider what you can communicate and what you can't communicate, and the importance of the critical review process or certification bodies. And we can provide a lot more information on that. So the third point is around digital systems. So I'm going to do a bit of a shout out to our product cycle here, which many large enterprises, both across mining, into cathode battery manufacturers and automotive, electronics, all that, they're using this across the whole value chain. Cycle is a really powerful life cycle assessment tool that can really accelerate you up that learning curve and get you modeling relatively quickly. So I mentioned some of our customer base, but they are some of the largest companies globally are using Cycle to help them comply with regulations, evolving regulations, and connecting directly to digital product passports. Some of the aspects on that around the features that allow this enterprise level work is automatic updates. So if you think about primary data coming from a mine, if they're both used, and then think about, say, the downstream customer, if they're both using the platform, if the miner updates their data, it can be synchronized directly with the downstream customer. There's collaboration features that allow multiple people within organizations and across organizations to be able to use this product as well. And I've just given you a very quick visual to show you kind of what this looks like. I've got an example of nickel sulfate. This is just an example of actually an eco-invent data point. But you can see exactly where the impacts are coming from. You can look at the different impacts of the intermediate products. And I mentioned earlier in the presentation, this is actually looking at the electricity impact contributions across the whole value chain of that nickel sulfate production. So it allows you to understand where the decarbonization of electricity could be a potential for that particular route. So we have this life cycle assessment. LCA is super important, like a super important provider of data that will then fit into digital product passports. So then I've just done a few slides in terms of our experience with this, especially with the Global Battery Alliance battery passport pilots. A little mouthful there. But I think some important things around considerations when you're building these verified product carbon footprint life cycle assessments for digital product passports. So we can talk about falsification detection, a really important auditability and version history. Very important to have approval processes and digital product passport integrations. There's also some key aspects that I thought I'd just raise here around key elements of the EU battery regulations across lithium-ion battery value chains. So, firstly, with the, I'm sure this has already been discussed, but all batteries will have a clearly visible QR code that provides all the information, composition, capacity, durability. One thing I would mention is I think batteries are really just the start. There's a lot of regulations that are in development phase. So mostly there's a regulation in the EU called the ESPR, and that's going to affect a much broader set of products across Europe. So I think product passports are coming quickly, and they're going to be here to stay, and they're going to be across so many different products. People want to know the history of the products. They want to know the safety of the products. They want to know the environmental credentials of a product, and they want to know the value chain of products. But related to the specific battery passport and the EU battery regulations, the digital passport, which I think has been discussed in the timeline, which is coming up very quickly, which will inform about the technical details as well as the percentage of recycled materials. Again, that data can be captured in cycle and within life cycle assessment. A due diligence policy to reduce social environmental impact. And the important point is it's mandatory to calculate the carbon footprint of each battery for its entire life cycle using life cycle assessment. And not just calculate the carbon footprint, but it's mandatory to also have primary data in a certain part of that value chain as well. So I mentioned the importance of primary data. I think this is quite a useful slide. It's quite complicated in terms of the amount of standards and how standards sit on standards and get more specific. But I mentioned at the top of the call around the ISO standards. That's, you can kind of think of that as the original LCA standardization. So it sits under the ISO 14000 environmental management standards, and then you have the ISO 14040 and 14044, which is for life cycle assessment. You have 14067, which is specific to the carbon footprint of products. So those are the top level standards. And then you have the European, product environmental footprint standards, which are more specific. So, you might have product environmental footprint rule sets and PEFCRs, which are the sort of guidance around that. And then you might have industry guidelines, which again are specific, but should sit on top using the same principles of those underlying ISO standards. And then you have at the very bottom, this is kind of a final sort of niche of the standards, which reads from the top of the more general to the specific, which would be the EU battery regulation specifying the carbon footprint for the batteries. So I thought I'd finish off just talking about the work that we've done with digital product passports. So we've done the Global Battery Alliance battery passport pilots for a couple of years now, where we've managed workflows and primary data collection for material producers, working with some of the biggest battery manufacturers globally. So we've worked with Gotion, Sunwoda, and we've got a number of other public digital product passport pilots being worked on this year with other major manufacturers. So again, the specifications of that include the identity, composition, performance. I can actually pull you directly into the link of these of the website of the Global Battery Alliance, which is where these digital product passport pilot results are hosted. So these have the pilots produced with Minviro, so Gotion, Smart, and Minviro, as well as other digital product passports that were used or created in this pilot phase. I'll just go back here. And you can see these are kind of like, this is a slightly nicer visual of what the digital product passport output would look like, where you can go across the provenance and ESG performance data, all these different pilots from this particular one. So you can see with Sunwoda, PTL, and Minviro on this one as well. I thought before ending, I might just show you, practically, I showed you a little bit of a small GIF in terms of how the software looks. I thought I'd show you at a very high level what the battery regulation carbon footprint might look like, just navigating through our software. You can see we've got the manufacturing stage, and then we have all the different intermediate stages, and then we're going back to the precursor. You can see that we've got lots of these different, so this is the inventory that I talked about. This is the background databases that I talked about. And if we go on to the results, we can start to look at the impact results of all the different intermediate products, as well as the final product as well. So we'll just go on to the battery cell. You can see exactly the cumulative impact in this particular demo. We can see the absolute impact as well as the percentage impact. We could look at the impacts across all the inventory items, or we can look at just maybe the top, maybe we just want to know the top 5 contributors. So we can see the biggest impacts in this instance is electricity in this particular stage from China. We've got some graphite feedstock. We could also look at the impact contribution from the different unit processes. So we're looking at battery cell manufacturing has obviously been decarbonized quite heavily in this particular example, but we have graphite production and cathode active material being quite a high impact in this instance. And what you can see here, I've done loads of different scenarios historically, so you can see a load of different scenarios where we've looked at different sourcing, different manufacturing technologies, and I can just show you kind of how you would visualize some of these different, let's look at different graphite impact. We can start to look at some comparisons about how we would reduce some impacts. Let's just look at another production volume. So we can start in marginal difference there. So we can start to run scenarios and see which is going to be the optimized battery, or how we might improve that particular carbon impact of the battery over time. If I go back here, I think that was my last slide. I'm really open for anybody who wants to reach out, collaborate, learn more about the work that we do, I really encourage you to look at the white papers. There's a lot of material that I think would be very helpful for those that are interested in this topic. Yeah, and happy to take questions.
Okay, thank you very much to Mr. Robert Pell for your insightful presentation. And okay, please give a warm appreciation to Mr. Dr. Robert Pell. All right, from today's session, we can understand that life cycle assessment is not only a technical measurement tool, but also a strategic approach to identify environmental impacts across the entire battery value chain. Okay, thank you very much to Dr. Robert Pell. Ladies and gentlemen, now we will move to Q&A session. This session please submit your question through Zoom by chat box. Okay, I try to read in the chat box. Oh, perhaps this is a special question from Bapak Muhammad Firmansyah. Is there an Bapak Muhammad Firmansyah? Do you have any question to ask something directly?
Yes, thank you, Bagus. Well, such a great presentation, Mr. Robert and also Mr. Ray. Yeah, well, actually, I have a question regarding a second life, a price. Yeah, well, actually, when we're talking about the battery passport, well, actually, we know the function is for the traceability, but when we're talking about the EV market, yeah, so who will determine for the price, secondary pricing? Because, yeah, for example, in Indonesia right now, the EV era just begin like maybe 3 or 4 years ago, yeah, and they asking about the price, about how we can value the pricing, yeah. So my question is how to determine a fair price, market price for the secondary battery, depend of entire for the state of health for the battery and remaining of the life cycle, and a bit for the natural local regulation, because there is no regulation regarding the second life battery right now. So many of the stakeholder in Indonesia asking about how we can make sure, and because before the battery being scrapped, yeah, we know the process, the scrapping, yeah, but we know that the battery can be used in the second life for the other purpose. So how we make sure the pricing of the battery? Thank you.
Okay, thank you very much to Bapak Firmansyah. Perhaps this question is subjected to Robert Pell.
Yeah, and also Mr. Renaldi. Yeah.
Oh, Mr. Renaldi.
Yeah.
Okay, I'm sorry.
Mr. Renaldi and
Yeah.
both.
This question, okay, this question is subjected to Mr. Renaldi first, and the second to Dr. Robert Pell.
I see. Thank you, Mas Firman, for the question. I think maybe Robert, after this, can explain further regarding the best practice and the current practice in the European and UK. But as far as I know, yeah, indeed, in Indonesia, there is no such a regulation of used battery. Even the used battery is still categorized as hazardous material. So we need to coordinate with the government in order to discuss about how then we can evaluate the battery after price. But as a best international standard practice, as far as I know, there is a Shanghai metal markets. Shanghai metal market can be the standard of the battery price of the used battery price, but usually the practice of the used battery in China also, when they have the OEM have their used battery, they will have a tender. Of course, the standard following the minimum Shanghai metal markets, but the one that give more premium is able to offtake the used battery. So that's something that I know from my knowledge, and I think this also a serious topic discussion that we need to push to the government. Yeah, please, Robert Paul, if you have other perspective, thank you.
Yeah, it's a very good question, and it's quite a complex one. I think it depends on number of factors. So firstly, you have some regulations which are kind of competing in a way to second life use of batteries. So, for example, if you think about there's circularity metrics and minimum recycled content requirements in new batteries, and so there might be an incentive there to push to recycling of those batteries rather than second use. I think the pricing, yeah, I mean, I agree with Reynaldi that the standard approach like that is, but it's so dependent on the unique chemistry of the battery, the state of health of the battery, and I suppose the other aspect is like the potential market demand for the second life application as well. And then layering all of that around as well. One thing that I think is very, very important is around, which links to the state of health, but is around safety. So the regulations around safety of second life of batteries. But I think that ultimately it's the market that determines the price, the willing price to pay for second life of batteries. And it's not as simple as what exactly, it kind of is a supply and demand question as well, based on that.
Okay, thank you very much to the question. Okay, the next question, I try to open the chat box, and there is a question from Zahra Kamila. This question is subjected to Bapak Rinaldi. Given that battery passport requirements are expected to become mandatory in Indonesia, and considering NBRI's role in supporting standard translation and implementation, have you seen any occurring bottlenecks or challenges from either government agency or companies when attempting to comply with passport requirement? In practice, what have been the most significant barriers? Perhaps to Bapak Rinaldi
Okay,
can answer this question.
Yeah, I think, yeah, the bottleneck, of course, there are several bottlenecks that must be addressed. We are not ready yet for the platform. We are not ready yet for the regulation. We are not ready yet for the whole ecosystem. So, of course, it takes time. And as I mentioned in my presentation, the government should start the initiative for this battery passport agenda, because it involves multi-ministry, it involves multi-companies, it involves multi-stakeholders. And in Indonesia, we don't have example yet of the product that has a good traceability. In agriculture, the product that has a good traceability, mostly like coffee and what else? Coffee and palm fruit. It can be traced, but other than that, it's rare in Indonesia that we have the traceability. So this is the challenge, and also the platform. So that's why we are here also engage with MindViro that already make a pilot project for the battery passport implementation in several areas. So we want to extend their expertise here so we can prepare the foundation of Indonesia battery passport to comply with the global battery standard. So yeah, I think the bottlenecks it's the system in our country, multi-ministry coordination that we need to be coordinated because in battery industry there are at least 10 ministries involved ranging from Ministry Investment, Ministry of Energy and Mineral Resources, Coordinating Ministry Economics, Ministry of Industry, Ministry of Transportation, Ministry of Trade, Ministry of Law, Ministry of Environment, and many more. So at least 10 ministry involved in the battery industry. So that's why the bottleneck is the coordination system. But if then the government hear this and they make a task force so the bottleneck can be resolved. I think that's main challenges in establishing the battery passport ecosystem in Indonesia. Thank you.
Okay, thank you very much to Bapak Rinaldi to insightful answer. Now we will continue the next question from anonymous attendants. This question is subjected to Robert Pell. Indonesia is rapidly becoming a major hub for battery material and battery manufacturing. Based on MinViro's experience, what are the key sustainability and traceability challenges Indonesia should address to meet future battery passport and international market requirements? Okay, Mr. Robert Pell.
Yeah, it's a really good question, and I think that my view is that there should be an education piece around, because I think life cycle assessment is a very new topic for many organizations. So I think that there is an education piece for organizations, and I think that education piece shouldn't just be. So there's a technical education piece, but there's the education piece around the value of life cycle assessments, why it can be valuable for these businesses as well. That's what I try to present. That a lot of the value is actually around understanding how you can be better as an organization, where you can reduce costs, where you can be more efficient, which is also a very important point to maintain that sort of strong position in the market. So I think education is a really important piece, and who would lead and drive that? I think there's some organizations there that are obviously on this part of this call that are really well positioned for such activities. I also think that part of it is demonstrating excellence in the sector. So if you're able to demonstrate case studies of organizations that are maybe a little bit further up, they have the resources to maybe move further up in terms of maturity. And I think it's that those demonstrations that these are, again, I think it's collaborating with international organizations as well, to demonstrate those case studies showing that there's like excellence, which is internationally accepted for the EU regulations would be a really good thing to do. And then there's also, the implementation challenges of how do you then implement that across the sector as a whole that's fast evolving. And I think some of the things that can support with that implementation and scaling is digital infrastructure. So like Cycle that we presented, providing that access to organizations to help them. It reduces the burden on the organizations and helps the sector as a whole scale.
Okay, thank you very much to clear answer, Dr. Robert Pell. And next, we will continue our question from Gus Adi. Yeah, this question is subjected to Bapak Renaldi. How could a company integrate the Environmental Product Declaration or EPD label on their product to support a battery passport scheme? Do they need to reassess their product or it just need a small adjustment to DPP standard? Okay, Bapak Renaldi.
Yeah, I think this question should go to Robert that already delve deeper about the battery passport.
Yeah, it's a good one. Unfortunately, the EPD is not identical to the Delegated Act and what the data will go on the digital product passport. That being said, a lot of the hard work will already have been done if you've collected the data for an EPD, because there might be a lot of common inventory data. So it won't be a huge challenge. That being said, something that's unique to, it'll be a different verifier. So for the EU battery regulations, you need a notified body, whereas it's a program operator for EPD. So it'd be a different verifier.
Thank you very much to Dr. Robert Pell. And the next question is from Prof. Evi to Dr. Robert Pell. Okay, I try to read. Have you done LCA for LFP types batteries compared with lithium nickel batteries? Technologies in battery processing is improving. How do you incorporate the technology change into the LCE?
It's a very good question.
LCA,
That's a very good question. Yes, we've done LCAs across multiple battery chemistries, both current technologies and prospective technologies. So we've done LFP, different NMC chemistries. We've done some solid state batteries even, and some sodium-ion battery LCAs. And again, a lot of those white papers are publicly available. Again, you have to go back to the goal and scope of the study, because what are you measuring the impact of? So if you're doing a direct carbon footprint comparison of one LFP battery versus an NMC battery, the results don't mean much because the performance of the different batteries might be quite different. And so you really have to it depends what application the batteries are being used for. But the hotspots are obviously going to be different because they contain different materials. And I think the second part of that question is, you are 100% right that technology change is so quick in this sector. Batteries are evolving in terms of their chemistry. Even when gigafactories or manufacturing of battery plants go online, that's so dynamic as well. You might have much higher scrap rates in the first few years, and then those scrap rates will drop off. And so you really need to consider this again when you're conducting the life cycle assessment. How do you capture that change? And when you're looking into the future, you can use an approach called prospective life cycle assessment. So you're kind of forecasting what the impacts are going to be, and you have to make assumptions about what's going to change in that technology, or is there going to be efficiency improvements in manufacturing? But that's a really good question, and it's definitely the exciting research part of LCA.
Can I continue a little question?
Okay.
More question.
Okay.
So which one should be done first, the LCA or a battery passport? Or battery passport should be the LCA data? I think which one? Because it seems like it's with one. Yeah, one requirement. Yeah.
So a battery passport without the information isn't very useful. So you'll follow a QR code, but it goes to nothing. So I would always say that having an LCA first to fill the battery passport is very useful. You'll obviously have other technical information about a battery in a battery passport, but I think the life cycle assessment is a critical part of it and can really support in the understanding of the supply chain and where the impacts lie for a battery.
So another further question, it is why specifically in Europe want to make the passport? So how about how the European consider for the other country? I mean, will they make like China their own passport, or will they follow the European passport? Or how? I mean, it's like my point. It's like the European want to limit the access. Coming should be a good thing that can be traced. Not
Yeah.
anything can come to the country, isn't right?
It's a very good question. Firstly, I'd say I'm English, and we had Brexit a few years ago, so we left the European Union so we're not directly influenced. But I can say from the perspective, from what I understand, there obviously is a sustainability. There's a sustainability aspect to it, but there's obviously control around what's coming into the EU as well, which I think is part of it. I think that it's broadly a good thing for transparency. And we're seeing a lot of other regulations which are really directly affecting trade, things like CBAM. The intention of these is obviously, if you think about the EU, and the UK, we don't manufacture much. Very little of our impact is in the manufacturing stage, but a lot of the impact is in things that we purchase in the supply chain. And so you can imagine that a lot of these regulations are that's the lever that the European Union has to reduce the impact in the supply chain.
Okay.
And on the question, sorry.
Yeah, continue, please.
No, and I was going to say, on the question of competing battery passports or sovereignty of battery passports, I think that really is a risk. If everybody's using their own battery passport and nobody's sharing information, then it doesn't become very useful at all.
Yes, because you will know everything inside there. And then maybe a little bit technical. Who will certify the state of health of the battery?
So I don't know this specifically, but I'm going to make a guess here, which is that because it follows the same approach broadly under the battery regulations, which is they will appoint, so they have notified bodies. So you have each country in the European Commission will have almost like a regulator or scorer of which organizations are qualified enough to be able to do that assessment. And they do that for the carbon footprint, but I imagine they'll do that for the other credentials as well.
Okay. Thank you, Robert. Yeah. I have one question for Rinaldi. Is it okay?
Okay.
The question is, how do you think about Indonesia? When Indonesia should start about the battery passport? That's my question.
I think we should start as soon as possible, Prof. Otherwise, we will lose the market because it's undeniable. Even though China is a big market, European is the market of NMC. So our nickel is absorbed mostly by European and American and UK. So Western countries, because they need a performance. In China, they only use mostly of LFP. So we lose a lot of potential market if we don't implement the battery passport. So I think the next step, we should knock on the relevant ministry to start this implementation. Maybe we can start from the Ministry of Foreign Affairs, then asking Ministry of Foreign Affairs to circulate the information of the implementation of battery passport regulation.
Well, you see, start not from the technical ministry, but from the diplomacy, right?
Yeah, because it's a regulation standard.
Okay. Thank you.
Thank you, Prof.
Okay, thank you very much to Prof. Evi for your nice question to our panelists. Okay, I try to read some question again on the chat box. Okay, from Fahrudin. Yeah, this question is subjected to perhaps to Bapak Rinaldi. Okay, in the future there will be a lot of old battery to recycling, but is it really economical value when new battery will more cheaper, such as natrium sodium ion comparing to the lithium ion? And the other hand, for SSB, yeah, it is hard to recycling solid state battery.
Yeah. First, in terms of technical aspect, we are still waiting those products, sodium ion, solid state battery, to be commercialized. I mean, there are many initiatives, but still on the pilot scale, not a massive commercial product deployment. So what I think is we should see this ecosystem as the historical more than the future. The battery recycling is all about talking the battery that has been produced. So even though the future battery can be more cheaper than current battery, but the waste of the current battery needs to be maintained, needs to be processed. Otherwise, it will be a waste battery that is not good for the environment. So my understanding, even though the future technology battery of solid state and sodium ion will be cheaper, the current battery needs to be processed. The current battery needs to be circulated into the battery materials. And I believe in many countries currently they already implement the mandatory recycling. So yeah, in the current recycling, the price of the battery, the black mass, it's less than a half of the price of MHP. So that's why the 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 demand of the black mass currently is increasing significantly, and we have already 100,000 electric vehicle on the road. So we need to think about how we maintain this waste. So yeah, I think it's not which battery will be more cheaper. It's all about how we can build the sustainable ecosystem. So I think my perspective is like that. Thank you.
All right, thank you very much to insightful answer to from Bapak Renaldi. Okay, I try to read the next question. Okay, from anonymous attendance. Okay, perhaps this is question is subjected to Mr. Robert Pell. What are the quick wins for companies to ensure that they are aligned with sustainability and the global regulatory compliance? Okay.
That's a really good question. So one would be ask your customers what they care about, because especially if those customers are exporting to global markets, they might have views on what they should be prioritizing. I think there's, depending on the maturity of the company, you can always work with an advisory company that can give you sort of an evaluation of where they think the risks would lie for sustainability regulations and compliance requirements, both from a local perspective, but more sort of global regulation market perspective. My view would be start adopting early stage. We're obviously massive advocates of the approach of life cycle assessment. So we would always be start adopting processes for life cycle assessment, because it's not just something that you can switch on with an organization. It requires that education piece, and you need people to sort of come on the journey and understand how to do it. One thing I would sort of acknowledge to that question, there is an enormous amount of noise, and it's really hard to understand what to prioritize in the market, because you've got so many voluntary standards and then so many like mandatory standards that might exist as well. So I would say working with a specialist can sometimes help with that.
Okay, thank you very much to Mr. Robert Pell, and we really appreciate it to our distinguished speaker, to Bapak Renaldi Istanto, as well as to Mr. Robert Pell. Okay, is there any question again? The last question, you can ask anything directly to our distinguished speaker. Perhaps, is there any question again? For the last question, okay. I have one opportunity.
I have a question.
Okay.
Mr. Bagus. In the chat box,
perhaps you can introduce yourself.
Yeah, I'm from Green Subhan. I have a question in the chat box. It is for Dr. Robert Pell too. I just want to know your opinion about I asking about in the future there will be a lot of our battery to recycling, but it is a really economical value when new battery will be more cheaper, such an ion comparing to lithium ion. Yes.
So for sure. So I mean, my
Perhaps you
view
can
is
answer again. You can answer again.
Yeah.
So my view is that Rinaldi's comment was absolutely right. That there's two parts to this question. One is that there is a waste. You know, you can if it doesn't have a market, then it's a waste, and there's a waste problem. What do you do with that waste? In terms of the market economics, you know, I think there is prices are very low for primary production. But that's not always going to be the same. You're going to have fluctuating prices, and I think that's going to change dynamics over time. Where, you know, if you have increasing primary production, or like, you know, if there's not enough investment into primary production volumes drop, then secondary is going to be a very important source. Sodium ion isn't going to become cost competitive and more efficient and more usable in every applications. You have an opportunity for these battery chemistries to all operate in a market, but just have slightly different applications. Like everybody, I think, was very bullish on NMC for a while, and then LFPs had a few years of real scaling and growth. I'm sure we'll see the same with technologies like sodium ion and potentially solid state, but at the end of the day, they all have different performance characteristics, which means they all have different markets. And so even if you have NMC battery chemistries coming offline, I think you'll find applications for those materials. And it doesn't always need to be a closed circular economy to the same, you know, you can get nickel recycling or manganese recycling, which could find itself in different applications as well in the future. So it's quite a complicated question and probably not a very clear answer, but overall the market is expanding, and so you tend to find uses for these materials.
Okay, thank you very much to Mr. Robert Pell for your insightful answer. Okay, that is the end our session, and please give a big applause and warm appreciation to our distinguished speaker, Bapak Rinaldi Istanto and Mr. Robert Pell. Okay, thank you very much for your insightful presentation.
Thank you, Rob, and thank you, Pak Ray.
Thank you, Prof. Evi.
Okay.
Very great.
Thank you, Robert.
Okay,
Thank you very much, Ronaldo.
Thank you, Bagus.
Thank you very much.
all right. Before we close our webinar, let me introduce our several key points from our discussion. The first is about the sustainability in lithium-ion battery industry. Is not only about the reducing emission, but also about the responsible sourcing, efficient production, and better end-of-life management. And the second, international sustainability standards are essential to help Indonesia's downstreaming battery ecosystem to meet global market expectation and improve industry competitiveness. And the third, about the LCA, life cycle assessment, provides a comprehensive method to identify environmental impacts across the entire battery value chain from raw material to recycling. Okay, before we close our today's session, we kindly request your time and participants to complete a short survey from us. The survey link can be accessed through the chat box as well as the QR code displayed on the screen. Okay, we kindly encourage all distinguished guests to take a moment to complete the survey display on the screen. To all participants, you can use your handphone to capture this QR code, because your feedback is highly valuable to us and will greatly support us and improving our Zoom webinar in the next event. Yeah, it's only about 2 until 3 minutes. Okay, I will give your time 2 minutes to fulfill this webinar survey. All right. Thank you very much to your to fulfill the survey. And as mentioned earlier at the beginning of the session, this battery talk is a part of Road to the International Battery Summit 2026, which will take place on August 26 to 27 at Jakarta International Expo Convention and Theater Kemayoran. And also the Battery Show Asia Indonesia 2026, which will be held from September 2 to 5 at Jakarta International Expo Kemayoran. The Battery Show Asia will be held alongside Electric and Power Indonesia, as well as Data Center Asia Jakarta 2026. For that, we kindly invite all distinguished guests to complete your pre-registration and to stay connected with the latest information, gain priority access, and receive update leading up to the International Battery Summit 2026. And don't forget to follow our social media channels and to stay updated with our latest information. We would like to extend our sincere gratitude to all distinguished speakers, our esteemed moderator, and all participants for joining us today. Our appreciation also goes to Minviro for their support in making today's webinar possible, and we hope today's discussion has been both valuable and inspiring for all of us. I'm Bagus Anggraini as a moderator in the session, and thank you very much. Good afternoon, and see you at the next Battery Talk session. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, terima kasih.
Mas Bagus.
Yeah.